Hello and welcome. Today, we're diving into a really powerful tool for analyzing electrical circuits. Sometimes you run into these circuits that have multiple power sources all working at the same time. And it can get, well, complicated. But it turns out there's a super elegant trick to simplify these problems, and it's called the superposition theorem.
Electro knowledge. Power up your concepts.
Here's our game plan. First, we'll set the stage and look at the kind of problem this theorem solves. Then, we'll get into the core principle itself. After that, we'll walk through the methods step by step with a real example, and we'll wrap up with the essential rules and limitations you have to keep in mind. All right, let's start with the problem itself. Picture a circuit that isn't just powered by one simple battery, but has a few different sources pushing and pulling current all at once. So, take a look at a circuit like this one. You can see we've got both a voltage source and a current source in the mix. Now, if you wanted to find, say, the current flowing through just one of those resistors using standard methods, you'd be setting up a whole system of simultaneous equations. It's doable, sure, but it's also a great way to make a simple math error. So, this begs the question, right? Is there a better way, a simpler way? And the answer is a big yes. The superposition theorem gives us a method to break this whole thing down into smaller, much easier to solve pieces.
So what exactly is this elegant solution? Well, the core idea is all about breaking the problem down. It's about focusing on just one thing at a time, which is a pretty powerful strategy for any kind of problem, really.
And here's the formal principle. What it's really saying is that the total effect, whether that's a voltage or a current somewhere in the circuit, is just the sum of the individual effects from each power source, as if each one were acting all by itself. So instead of one big messy problem, you get to solve a few simple ones. It's a classic engineering divide-and-conquer approach. Okay, so that's the big idea, but how do we actually do it? Let's get practical and lay out the exact method you need to follow.
The process is very methodical, which is great. First, you pick one source and one source only. Then, and this is the magic step, you turn off all the other independent sources. You solve that much simpler circuit, write down your answer, and then you just repeat that whole process for every single source. At the very end, you just add up all the individual results you found.
Now that phrase, turn off, is key. How do we do it properly? Well, for a voltage source, to make its voltage zero, you replace it with a short circuit, basically just a plain old wire. For a current source, to make its current zero, you replace it with an open circuit. You literally create a break in the wire so nothing can flow. Getting this right is absolutely crucial.
And here's a super important catch. This rule about turning sources off only applies to independent sources. Dependent sources, the ones that get their value from somewhere else in the circuit, are treated differently. You just leave them alone. Think of them as part of the circuit's furniture, like resistors. They stay active in every single step.
All right, theory is one thing, but let's actually put this to the test. We're going to walk through an example with some real numbers and see exactly how this works.
Okay, so here's our circuit. We've got a voltage source, V1, and a current source, I1. And to make it interesting, we've also got a dependent voltage source in there. Our goal is to find all the currents and the voltages at each node. First up, let's figure out what the 10-amp current source is doing all by itself. To do that, we need to deactivate the 120-volt source. Remember the rule, we replace it with a short circuit. And of course, that dependent source just stays right where it is. We don't touch it. So, with that voltage source out of the way, the circuit is way easier to solve. We run the numbers, and here's what we get. These are the contributions from only the current source. For example, the current I2 is 15 amps, and the voltage at node B is 150 volts. We'll just set these results aside for a moment. Okay, round two. Now we're going to find the contribution from the voltage source, V1. So we put V1 back in the circuit, and this time we deactivate the current source. The rule for that, we replace it with an open circuit. And again, our dependent source hangs out untouched. We solved the second simplified circuit, and here are our results. Now check this out. Notice that the value for I2 is now negative 12 amps. That's not a mistake. That sign is critical. It just means that with only the voltage source active, the current is flowing in the opposite direction.
All right, here comes the fun part. We've done the hard work, we have the results from each source acting alone, now all we have to do is put them together.
And here it is, the final synthesis. This table shows our results from both steps, side by side. To get the true total response, we just add them up. Let's look at I2 again. We have 15 amps from the current source, plus negative 12 amps from the voltage source. Add them together, and the final, actual current, is 3 amps. Or for voltage VC, 0 volts plus 120 volts gives us a final answer of 120 volts. See, it's that simple.
So superposition is a fantastic tool, almost like a cheat code for circuits. But like any powerful tool, it comes with a user manual. It's really important to know when you can use it, and maybe even more importantly, when you can't. So, your circuit has to be linear and bilateral. But the last rule, this is the big one. This is the one that trips people up all the time. You cannot use superposition to find power directly. Why? Because power calculations, like I squared R, are nonlinear. You can't just add the power from each step. You have to find the final total current or voltage first, and then use that final value to calculate the true power.
You know, this whole idea of divide and conquer isn't just a trick for electronics. The principle of superposition shows up all over the place. In mechanics to analyze forces, in physics to understand waves, even in things like project management. It's a powerful reminder that sometimes the most intimidating problems become manageable if you just have a strategy to break them down and tackle them one piece at a time.
Thanks for watching. Like, share, and subscribe to Electro Knowledge for more electrical concepts.